as we wrap up our discussion on standard normal distributions and t-distributions, I just want to take us full circle back to sample size determination. So we talked in the previous videos about determining sample size. And when we are setting up our research project, we want to make sure we have sufficient sample size, because if it is not small enough, we're not able to estimate those population parameters. If it's too large, we're wasting a bunch of money. So we really want a big enough sample size, but not too big. And we had talked in previous videos about how to determine the sample size. We found the sample size for problems where we summarize them with means, and we found the sample size when we have problems that are summarized with proportions. And at the time you saw these formulas, you plugged in numbers, you figured out the sample size. But now that we have more fully spent time on our z-scores and how to find those z-scores with proportions and means, I just want to take you back to these formulas one last time so that you can actually see where it is this came from. So the sample size is going to be based on the level of confidence, right? How confident do we want to be in our results? So this is tied directly to these confidence intervals we've been talking about. It's also going to be based on the maximum allowable sampling error. So how far away are you willing to let your sample statistics be from your population parameter? And it's going to be based on the variability in the population. The more variability in the population, the larger the sample size we're going to need to make sure we represent those differences. Well, where did those sample size calculations come from? They came from rearranging these formulas that you've seen before. So if we took that formula and we rearranged it to solve for n, we end up at this formula that we had earlier when we were looking at research design. And now you know where all of this comes from, right? This one here is the variability in the population. You know that this is our 1.96 if we are going to be 95% confident. And then E squared is that amount of sampling error that we are willing to have, how far that x bar minus mu can be, and then of course squaring that difference. So all of this comes from rearranging this formula that you've already seen. And same thing, I don't know where it is, somewhere. This formula here that we've seen before, if we rearrange that and solve for n, where do we end up? We end up at the formula that you've seen before, where our Z is based on our confidence level, right? 1.64 for 90%, 2.58 for 99%, P times 1 minus P, and E squared being the sampling error, how far apart are P hat and P, and then squaring that. So these sampling size calculations that you did previously come from just rearranging these formulas that we've been dealing with in our last couple of videos. So I won't repeat all of these sample size calculation methods and how to do this. You did that with the previous videos, but I just want to show you where they came from.